When it comes to selecting the best meat, understanding the quality criteria for different types is essential. Let's dive into what makes pork, lamb, and beef top-notch. For pork, the color should be pale pink to light red. You definitely want to avoid any grayish tones. The fat should be white and firm. Steer clear of yellowed or soft fat. The texture should be firm and elastic. If you press the surface gently, it should spring back. Smell is also crucial. There should be no off odors. Sour or ammonia-like smells indicate spoilage. Lastly, check the packaging. There should be no excess liquid or bloating in vacuum-packed pork. For lamb, the color should be bright red. Darker tones might indicate aging or poor storage. The fat should be white and firm. Yellowing suggests the lamb is not fresh. The texture should be fine-grained and firm. Sticky or slimy surfaces are a definite sign of spoilage. The smell should be fresh and mild. Strong odors suggest bacterial contamination. For beef, the color should be bright cherry red due to oxymyoglobin. Dark purple or brown can indicate oxidation, but isn't always spoilage. The fat should be creamy white or slightly yellow and evenly distributed. Marbling adds quality. The texture should be firm and dry. Slimy or sticky textures indicate spoilage. And of course, the smell. There should be no sour or rancid odor. Game examples include venison, rabbit, pheasant, wood pigeon, quails, and partridges. The color should be rich, dark red. Pale or greenish discoloration indicates spoilage. The texture should be firm. Slimy patches suggest bacterial contamination. The smell should be earthy and fresh. A strong gamey odor could indicate poor storage. Poultry. The color should be cream to yellow for the skin and the flesh should be pale pink. The texture should be firm and moist. Sliminess indicates spoilage. The smell should be neutral or slightly sweet. Sour or sulfur-like odors suggest bacterial growth. Packaging should have no tears or excessive liquid pooling. Offal or organs. The color should be bright and consistent. For example, liver should be dark red and kidneys dark brown. The texture should be smooth and moist. Avoid sticky or overly dry surfaces. The smell should be slightly metallic but not offensive. Strong odors indicate spoilage. Packaging should have tight seals and minimal liquid to ensure freshness. Spoilage indicators include sour or rancid odor, excessive dryness or stickiness, dull or darkened color, and green or brown patches. Ready-to-eat meats, such as sliced ham, cooked chicken, and cured sausages, have specific indicators of quality. Acceptable indicators include a fresh, pleasant smell, often with a mild salty or smoky aroma. The color should be even, with pink or light red for ham and golden for cooked chicken. The slices should be firm and hold their shape well. Now, let's talk about spoilage indicators. If you notice excess liquid in the packaging, that's a red flag. A slimy or sticky texture is also a sign of spoilage. Additionally, greenish or iridescent discoloration and a sour or musty smell are clear indicators that the meat has gone bad. One of the main sources of contamination is Listeria. This bacterium can persist in food production environments, especially in areas with cold, damp conditions like refrigerated packing rooms. It thrives on equipment such as slicers, conveyor belts, or packaging machines if proper cleaning and disinfection protocols are not followed. After cooking, ready-to-eat meats are safe, but they can be exposed to Listeria if the production area is contaminated. Contamination often occurs during slicing, handling, or vacuum packaging, as these steps involve direct contact with equipment and surfaces. Listeria forms biofilms, which are protective layers of bacteria that adhere to surfaces and resist cleaning. If biofilms are not completely removed during sanitation, they can release Listeria into food during processing. Listeria is psychrotrophic, meaning it can grow slowly at refrigeration temperatures, even at 4 degrees Celsius or lower, allowing it to multiply during storage if contamination occurs. Preventing Listeria in ready-to-eat meats involves several key practices. Firstly, strict hygiene is essential. Regular deep cleaning and disinfection of processing equipment help to prevent biofilm formation. Environmental monitoring is also crucial. Routine swabbing of surfaces, equipment and drains can detect contamination early. Maintaining strict separation between cooked and raw meat processing areas is vital to prevent cross-contamination. Temperature control is another important factor. Storing ready-to-eat products at 4 degrees Celsius or lower slows Listeria growth. Lastly, good manufacturing practices, such as minimizing human contact with cooked meats by using automated equipment where possible, are key in preventing contamination. What are biofilms? Listeria attach to surfaces and form a protective matrix known as a biofilm, which is resistant to cleaning with detergents. Approved biocides or sanitizers have to be used by meat processing establishments. This bacteria thrives in cold, damp environments and can form biofilms on surfaces such as shelves, drawers, or drainage systems. Fridges that are not cleaned regularly or have water pooling in certain areas can become breeding grounds for Listeria. Listeria in fridges can come from sources such as water buildup, unclean fridge surfaces, and contaminated foods like raw vegetables, deli meats, or unpasteurized dairy. Unlike many other pathogens, Listeria can multiply at refrigeration temperatures as low as 0 to 4 degrees Celsius. Once established, biofilms protect Listeria from cleaning efforts, making it more resilient. Prevention of Listeria in fridges involves regular cleaning of shelves, drawers, and drainage areas with detergent and disinfectant. It's also important to manage water properly by ensuring no pooling water and regularly checking and unclogging fridge drainage systems. Proper storage is crucial, so store ready-to-eat foods in sealed containers above raw foods to avoid cross-contamination. Finally, always monitor fridge temperatures to keep them at or below 4 degrees Celsius. Clostridium botulinum, why it's dangerous and how to prevent it, why it's dangerous. Spore formation. Think of spores as the bacteria's protective coat they put on when conditions get tough, like when it's too hot, cold, or dry. When conditions become warm and moist, like in food left in the danger zone of 8 degrees to 63 degrees Celsius, they take off their coat and grow into active bacteria. Spores are super tough. They survive cooking, freezing, and boiling. It thrives in oxygen-free environments like canned, vacuum-packed, or smoked foods. Toxins. Clostridium botulinum produces a powerful toxin that can cause botulism, leading to paralysis or even death if untreated. Clostridium perfringens causes food poisoning, leading to stomach cramps and diarrhea. Cooking meat to typical safe temperatures of 70 to 75 degrees Celsius doesn't destroy these spores. To kill spores, much higher heat, such as 121 degrees Celsius under pressure in a canning process, is required. Does meat naturally contain Clostridium? Yes, Clostridium spores are naturally present in the environment, like soil, water, and dust, and in the intestines of healthy animals. During slaughter, spores can contaminate meat surfaces. Why is cooking raw meat still safe? While spores might survive cooking, they need time and favorable conditions to germinate, such as warm, oxygen-free environments like improperly cooled leftovers. If the meat is cooked and eaten immediately, spores don't have the chance to grow. When does Clostridium become dangerous? Spores become dangerous after cooking if the food is improperly cooled and stored in the danger zone, which is 8 to 63 degrees Celsius, allowing spores to germinate into active bacteria. The environment is anaerobic, or oxygen-free, like in vacuum-packed or canned food, where germinated bacteria can produce toxins. By cooling food quickly, storing it properly below 5 degrees Celsius, and reheating it to above 70 degrees Celsius, you can prevent Clostridium spores from becoming a risk. Prevention: salt and preservatives. Use salt or curing agents like nitrates in processed meats to stop bacteria from growing. High levels of salt, for example in cured meats, draw out moisture, making it harder for bacteria to grow. Control temperature. Keep foods cold by storing food below 5 degrees Celsius. Spores are less likely to germinate at low temperatures. Avoid the danger zone, which is 8 to 63 degrees Celsius. Bacteria grow rapidly at these temperatures, so minimize the time food spends in this range. Control oxygen levels. Avoid oxygen-free environments if not treated properly. use additional hurdles like acidity, salt, or preservatives for vacuum-packed foods. Increase acidity. Maintain a pH below 4.6. Acidic conditions prevent spores from germinating. Examples include pickling or adding lemon juice or vinegar to foods. For ready-to-eat or processed foods, ensure acidifiers are part of the recipe. Preservatives. Use curing agents like nitrates and nitrites to inhibit spore germination. Moisture control. Reduce water activity by drying or dehydrating foods, such as jerky or powdered products. Low moisture environments are inhospitable for spore growth. Label storage instructions clearly. Keep vacuum-packed or pre-packaged foods at or below 3 degrees Celsius. Clean regularly. Maintain clean food preparation areas and equipment to avoid cross-contamination with spores. Pressure canning. For home canned goods, use a pressure canner to heat to 121 degrees Celsius for 3 minutes, which destroys spores. Vacuum packing. Combine vacuum sealing with other barriers like acidity and refrigeration. Differences in spore activity. Spore formation. Both bacteria form spores as a protective mechanism, but Clostridium botulinum spores are typically associated with low oxygen environments, while Clostridium perfringens thrives in bulk-cooked foods where heat pockets might allow spore survival. Growth conditions. Clostridium botulinum primarily thrives in oxygen-free environments like canned or vacuum-packed foods, whereas Clostridium perfringens often grows in cooked foods that are improperly cooled or stored. Toxins. Clostridium botulinum toxins are neurotoxic, causing paralysis, while Clostridium perfringens toxins affect the gastrointestinal system, leading to diarrhea and cramps. Common bacteria related to meat include Listeria, Salmonella, Staphylococcus, and E. coli. Pathogens associated with meat products vary by type. For pork, Trichinella is a parasite that causes trichinosis, often from undercooked pork. To prevent this, cook the meat to 75 degrees Celsius and freeze it for extended storage. In lamb, Campylobacter is a zoonotic bacteria linked to cross-contamination in raw lamb. Prevention involves avoiding cross-contamination and cooking to 75 degrees Celsius. Toxoplasma gondii, another parasite, causes toxoplasmosis, particularly in undercooked lamb. To prevent this, cook thoroughly and avoid handling raw lamb if pregnant. For beef, Brucella causes brucellosis, transmitted through undercooked or contaminated beef. Prevention includes inspecting carcasses for signs of infection and ensuring thorough cooking. E. coli can be found in undercooked ground beef, and Listeria monocytogenes is a persistent risk in ready-to-eat beef products. Prevent this by cleaning equipment regularly and ensuring cold storage at or below 4 degrees Celsius. Salmonella, found in wild animals due to environmental contamination, can be prevented by practicing proper hygiene when processing game meat. In poultry, Campylobacter is the leading cause of foodborne illness. Prevent this by cooking to a core temperature of 75 degrees Celsius and avoiding cross-contamination. Staphylococcus can grow in improperly stored or cooked poultry, so it's essential to avoid time temperature abuse. Offal, such as pig liver, can be contaminated with hepatitis E virus or HEV. Prevention involves ensuring proper cooking and sourcing. Signs of spoilage for pre-packed meats can be quite telling. For vacuum-packed meat, discoloration or green patches indicate oxidation or microbial growth. Packaging bloating may result from gas-producing bacteria. In canned meats, swollen or leaking cans signal Clostridium botulinum contamination. Rust or dents can compromise the can's integrity, indicating potential spoilage. Fermented meats use starter cultures to produce lactic acid, lowering the pH to below 4.6. This process results in a dry texture and uniform curing, which are indicators of quality. While a white surface mold is normal, green or black mold is a sign of spoilage. Additionally, off-smells or fuzzy molds also indicate that the meat has spoiled. If you notice a soft texture or moisture inside the packaging, it suggests improper curing. Curing examples include chorizo, salami, pepperoni, and prosciutto. This process adds salt, nitrites, or nitrates to prevent bacterial growth and enhance flavor. However, there are risks. Excess nitrites can form nitrosamines, which are carcinogenic. To control this, use approved levels as per UK and EU legislation. Quality indicators are a uniform color, firm texture, and a mild smell. Spoilage signs to watch out for include a slimy surface, sour smell, discoloration, or visible mold. Smoking serves a dual purpose. It provides flavor and, when combined with curing, preserves the meat by inhibiting microbial growth through dehydration and smoke compounds. But there are risks involved, as it can concentrate harmful polycyclic aromatic hydrocarbons, or PAHs. To control this, follow regulated smoking times and temperatures. Vacuum packing, for example, steaks and cured meats, removes oxygen to slow spoilage. However, it carries risks such as the growth of anaerobic bacteria like clostridium botulinum. Controls include storing at 3 degrees Celsius or lower and ensuring airtight seals. Acceptable indicators of quality are tight, intact packaging with no air pockets or leaks, normal color, which may be slightly darker or purplish due to lack of oxygen but returns to normal after exposure to air, and no foul odor when the package is first opened, with any initial smell dissipating quickly. Spoilage indicators include a loose or broken vacuum seal, a greenish or iridescent sheen on the meat, a strong, persistent sour or sulfuric odor after opening, and a sticky or slimy surface. For smoked meats, such as smoked bacon, smoked turkey, and smoked sausage, acceptable indicators of quality include a slightly dry exterior with a smoky aroma, a uniform golden brown to reddish hue from smoking, and a firm texture without excessive dryness. Spoilage indicators to be aware of include discoloration, such as green, grey, or black spots, a sticky or slimy texture, an off-smell that is sour or musty, indicating microbial growth, and excessive liquid or pooling in the packaging.